Now let's see how we would define both an inertial and a non-inertial frame. So first let's set up a set of axes. So we'll have the x-axis and the y-axis. And then let's say we have some object in it, object A, and it's moving with some velocity VA. Okay? Now, what we do is we say our new frame of reference is going to be this frame with our object located at the origin, and we'll call this x prime and y prime. Okay, so this is our new reference frame. This is the frame. This is what we would see if we are at A, which to us seems stationary. Okay, and then let's say now that we have a second object B, and B will be over here, and we want to find out where B is relative to A. So we've already done this in terms of vectors, right? We know that the position of A we can write as RA. We know that the position of B we can write as RB. And then we'll have a new vector here, which we'll call RB prime. And this is B's location in terms of A's coordinates. Okay? So again, just adding vectors, we know that RB is equal to RA plus RB prime. Or in other words, the new location of B, RB prime, is equal to RB, the position in our non-moving frame, minus RA, so the position of A. Okay, so this is how we can write our position in terms, in terms of the location from that A would see B at. Okay. Now the next step is, again, we said that particle A is moving with some velocity VA. So if A is moving, even if B is stationary, and let's say for argument's sake that B isn't stationary. Let's say that B is also moving, and it's moving with some velocity B. Okay, then we can say that the velocity of B is equal to, well, actually the easiest way to do this is we'll say that the velocity of B is the derivative of RB dt by definition, which is the derivative of RA dt plus the derivative of RB prime dt, which we call VA plus VB prime. So in other words, VB prime is the velocity that A sees B moving at, and that's equal to the velocity of B minus the velocity of A. So now this tells us that if we are object A and we're traveling along with this some velocity, then this is what our apparent velocity of particle B would be. And then finally we can get the acceleration of B by saying, by definition, this is the derivative of velocity B dt, which is just going to be the acceleration of A plus the apparent acceleration of B in A's frame, meaning the acceleration of B compared to A is going to be equal to the actual acceleration of B minus the acceleration of A. Okay? And I'm going to make one slight change here, and I'm going to note that now in all of these, so this RA, this is really the position of the reference frame. This velocity A is really the velocity of the reference frame, and this acceleration A is really the acceleration of the reference frame, meaning we're always going to be in terms of this reference frame here, the x prime y prime frame, as it's moving. It's both has velocity and possibly an acceleration. Okay, and then in doing so, I figured out how to write both the position, the velocity, and the acceleration of particle B in terms of this new reference frame. Okay, and so in the next few videos, we're going to look at applications of this.